First things first, what is KNN? Imagine you just moved to a new city and you're looking for a good restaurant. You ask 3 locals and they all recommend the same place. Based on their opinions, you trust that this restaurant is probably a great choice. Congratulations, you just used the logic behind KNN. At its core, KNN is a classification algorithm that makes predictions based on the votes of its nearest neighbors. Instead of training a model with fancy equations, KNN memorizes the entire dataset and classifies new points by looking at the closest examples. It's super simple. Take a new data point. Measure the distance to all other points in the dataset. Find the k nearest neighbors, for example, the 3 closest. See which class appears the most and assign that label to the new point. It's a lazy learner, meaning it doesn't train in advance. Instead, it does all the work when it's time to predict something. That makes it easy to implement, but also slow on large datasets. All right, that's the first step of our journey into KNN. All right, let's get real for a second. Imagine you're at a party. You don't know anyone, but you spot 3 people wearing Metallica t-shirts, talking about AI, and drinking the same energy drink as you. Chances are you'd feel comfortable joining that group, right? That's KNN in action. Nearest neighbors works exactly like that. It groups new things based on their similarity to existing ones. No complicated training phases, no heavy mathematical modeling. Just pure pattern recognition based on proximity. But let's break it down step by step because there's more happening under the hood than just find your squad and stick with them. Step 1, data preparation. Before KNN can do its magic, we need a clean data set. And here's the catch. KNN is super picky about messy data. If your features are on different scales, like height in centimeters and weight in kilograms, KNN might get confused. So we normalize the data to make sure no single feature dominates the others. It's like making sure all the contestants in a race have the same kind of running shoes, no unfair advantages. Step 2, distance calculation. Now, this is where things start getting serious. KNN decides what's near based on distance. But not all distances are the same. Euclidean distance. Think of this as the straight line distance between 2 points, like a crow flying from one house to another. Manhattan distance. Picture this like navigating a city, zigzagging through streets instead of flying in a straight line. Minkowski distance, a customizable distance metric that lets you mix and match different styles. Choosing the right distance matters because if the dataset has weirdly shaped clusters, the wrong metric can give you totally misleading results. Step 3, finding nearest neighbors. Now we decide how many neighbors to check. This is the famous K in KNN. If K bar 1, we simply take the closest data point and assign its label. But if K bar 3, 5, or 7, we take a vote. Whichever class is the majority wins, but here's where it gets tricky. Too small a K? The model becomes sensitive to noise. One bad data point can throw off the whole prediction. Too big a K. The model oversimplifies and smooths everything out, potentially missing important details. It's all about balance. And if you're wondering, how do we find the best K? Don't worry, we're getting to that. Step 4, making predictions. Once we have our neighbors, the majority vote decides the final class. If 3 out of 5 nearest neighbors are cats, we predict that our mystery data point is also a cat. But here's a mind-blowing thought. KNN doesn't actually learn anything in advance. It just remembers everything and makes a decision on the spot. That's why it's called a lazy learner. Sounds simple, right? But don't be fooled. KNN has hidden weaknesses that can make it slow and unreliable in certain cases. And guess what? That's exactly what we're diving into next.